thank you for coming. So my name is Terry Arthur. I'm the Chief Microbiological Officer at Fremont. So formerly I was with USDA Ag Research Service, and that's where a lot of this work was done. Today we're going to talk about chicken sampling with the MIT method. It's a cloth-based method, and so I'll give you a little background. We'll go through some of the data we've collected and talk about what we're looking for in the future. So the MicroTally swab was developed in cooperative research agreements with USDA Ag Research Service. We got our initial letter of no objection for beef trim sampling in 2017, and we listed there the publications and Journal of Food Protection that have come out so far. These are all in sheep and beef track. 95% of the beef that's produced in the U.S. is sampled with MicroTally cloth. FSIS has, this is a slide taken from their validation set. FSIS went through, validated the MicroTally on beef and found it to be equivalent to the old excision method. And now they're using it as their standard method for beef trim sampling. So this is their slide. Sorry, this is the FSIS slide. So this is all, they collected their own data, did their own validation, and found it to be equivalent. And currently they're using it. That was with the 8 by 24 inch swab we used to use for manual sampling. Certain applications, could be more user-friendly, so we developed a MIT method. So this is the same material, the spun-bossed polymer fabric. It's ultrasonically stitched on the edges, so that's how the MIT is formed. And so it gives more, it's a little bit more user-friendly, it's a little bit more ergonomically easy for the employees, and we have shown that it's equivalent as the beef sampling to the swab and to the old excision method. So this is just an idea how it's used. Put on a glove can and sanitized glove, swab the 2,000-pound combo, take the sample, and this is a demo version. It's a little shorter than normal. Usually it's 45 seconds each side of the swab. Work your way all the way around the 2,000-pound combo, and that's your sample. We've done the first set. I'm not going to go through all this data. I'm just going to kind of skim over it. This is data I presented at IPPE. This is for turkey sampling. So this is using the MIT, comparing it to the FSI sponge method. And as you can see there, we have quite a bit more. So everything that's circled in red is significantly different in favor of the MIT. We had quite a few things. On the upper left panel is index or indicator organisms, so APC, AC. Next is the pathogen, Salmonella, Campylobacter prevalence. At the bottom are these index targets. So they're PCR targets that are similar to pathogen detection, but they are not so specific, so they don't cause you regulatory issues. But we can use them to get more information. And so, like if you take the post-chill on the right, top right, the post-chill samples for turkey, we got a lot of zeros. And so we need more data to analyze are these methods equivalent. So we'll use the index targets to add that data. We like it to be within a range of 20 to 80% prevalent, so we can run the statistics on it. This was still a little bit of background. That's where we were a while back with turkey. We had that data collected, and then it was time to move into the chicken sampling. So the project objective was to evaluate was the MIT sample equivalent to the current standard, which was rinse of one chicken carcass, or a rinse of 4 pounds of parts. These are rinsed in 400 mils. We used NBPW to be equivalent to FSIS. The MIT is pre-wet with 25 mils of NBPWs, and then the sample is taken. It's shipped back to the lab. All the samples were shipped back to the lab on ice and then processed the next day. All the data I'm showing today was collected in commercial processing plants with pathogen contaminated product. Nothing was lab, this, drive, or inoculate. These were for the turkey side, it was 4 commercial processing plants. For the chicken side, 3 commercial processing plants. On the chicken side, we did pre-hang, post-chill, and parts. The same analysis we saw last time. So we do the indicator organisms, we do APC and G enumeration. Those are useful. We do them more out of historic kind of people wanted to see that in it, but we don't believe it does us a lot of good. Process control, yes, but for some of these pathogen detection tests, we just do it. But you'll see that data is in there as well. Pathogen testing, Campylobacter and Salmonella prevalence, and then again the index targets to help get more data to me. Rinse was done, like I said, according to the FSIS method, 400 mils in PBW, shaken for a minute, liquid is poured off, and then sent to the lab. Mitt is pre-wet with 25 mils, sample is collected and sent to the lab. Once it gets to the lab, the mitt gets 200 mils of whatever enrichment buffs. So we left it open-ended for a detection platform, so you can use any detection platform with it. It's been validated. The matrix extensions have been done for Hygiena, bioMérieux, Eurofins. So anybody that has a test that we've worked with, so that commercial industries are working with, they've done the matrix extension. Mitt goes on. This is for single carcass sampling. So all we're doing here is showing that it's equivalent to a single carcass. Entire carcass is swabbed, 15 seconds each side of the mitt. This is a rehang. At post-chill, you would do the inner cavity as well. And that samples the whole burn. Equivalent recovery, we'll look at the data as the mitt. This is parts. So we put 4 pounds of parts into the poly bag, just like you do with eggs. And then you would take your sample, 15 seconds per side of the mitt, flip it over, and then take the rest of the sample and parts go back online. The check goes back into the sample bag it comes with, and goes to the lab for enrichment. For the indicators, same format, everything that's circled is significant. Blue is significant towards the rinse, and red is significant towards the mitt. You can see that the rinse was had a little bit more recovery. We have previously worked with beef and shown that indicator organisms can vary by half log per sample without changing the prevalence. And so you'll see when we get to the prevalence, if the prevalence is actually as good or better than on the mitt. We've seen it before. It's tough to know what a biologically significant change in indicator, especially as you can see, yes. We were granted a letter of no objection on the half log is considered equivalent on APC at EB. Once you get down to post-chill, the mitt was a bit better on HTC, and then the rest were equivalent at parts and on post-chill. So going to the pathogens, looking at salmonella, there was only one comparison that was significantly different, and that was at rehang, with the mitt being a little bit better than the rinse at rehang. And then as we go down, prevalence goes down, but they were equivalent at post-chill and parts. Campylobacter, also equivalent at rehang, equivalent at post-chill, equivalent at parts, but we'd like to see, that's where I think we need some improvement. It used to be, and we did it on turkey, where FSIS takes 2 samples, they split them out, one goes to salmonella, one goes to Campylobacter. And we did that for turkey, we took 2 mitts. It's not the end goal to have 2 mitts, so while I had 1. So out of this one, we took the 1 sample, added 200 mils, homogenized it, and then pulled out the 30 mils there. I'm a little worried we're getting a little too much dissolved oxygen for Campylobacter, so we had some. We're not bad, but only parts we have to work on. So a little bit of fish there. We had our pathogen index targets. Again, we had 4 cases where the mitt was significantly higher recovery than on the rinse. Just these additional data. So we use Intamin, which is a virulence factor-free coli. Flagella, also Shippable and coli, SPEC kind of thing. Pet resistance is a common resistance found in E. coli and Salmonella, and generic E. coli. So we use targets that are enteric oriented, closer than, say, APC or Enterobacteriaceae, something into it. We're adding targets as we go for Salmonella. We started in beef, so our targets are more feed focused, but still provides us useful data on recovery of total bacteria, and specifically that's closer to the bacteria business. From the data we've collected on here, the mitt was shown to be equivalent to the rates for collecting samples of chicken carcasses, chicken parts, and turkey carcasses. Just in December, we received a letter of no objection from FSIS for chicken sampling that can be used commercially and for food safety testing, and used in some places. We're hoping to start rollout into more places now. We're trying to work with groups as the framework comes out on what's going to be a better sampling method. The next steps, as we get into what the framework is going to be and how we go forward, is to how can we scale up to bigger lots. sampling one carcass or 4 pounds of parts isn't going to really get us to where we need to go. This is our mounted device. We call it continuous sampling device. It's going to, I'll show the video here in a second, it's going to sample the carcasses as they go by. So this is 10 minutes on the line. It'll sample 1,400 carcasses. We think maybe you can do that out of an hour to be representative what your hour production is. Do that time. On the left is going to be parts as they go by. Again, you can sample for some time period and say, okay, this is what you can sample the whole time you want. You think this is probably overkill, but you want a much more representative sample than that one carcass or 4 pounds of part. As the carcasses go by, they run against the mounted device, and it holds the MicroTally swab on there, so it's a little bit of a gradient that goes by. Also, it has some wicking ability, so it removes some of the moisture that's on there. That's where the bacterial recovery is going to be. The parts come down a chute or come off a conveyor, so this we use much more on the beef side. On beef trim, this comes off the conveyor, goes across the sampling device, and so you can sample several hundred pounds with minimal input. And then you just slide that cartridge out, put a new one in with a clean swab, and you take this one to the lab. Or you can put something in until that hour of production is done, and then wait till the next hour. Right now, the industry seems to be responsive to an hour-based lotting system, but still working on what's going to work for that. So any industry feedback we can give is all it's very useful. You don't want to make something that doesn't work for the intended use. So you can also take the Mitt online. On this, we're sampling 60 carcasses, 30 carcasses with one side of the Mitt and 30 with the other side. Very representative sample, more representative than single carcass. You can do more. It's just we're trying to figure out how long we want a worker there to take that sample. It's very easy. It's not, we're not getting enough near the line, so it doesn't look to be a safety issue. It's very easy like that. So the interesting thing, as we go from what does a rehang sample mean to post-chill. Rehang rinse right now, you still have the possibility of getting fecal contamination from the intestinal tract in that rehang rinse. Is that representative of your reduction going from rehang to post-chill? Here we can focus on areas, focus on the breast and the back and say, okay, we're going to look at that here at rehang and then post-chill and say, okay, we're comparing the same thing. We're not having a kind of inflated reduction. We want to really make sure. If you want to get sample closer to the vents, you can do that. No problem with the Mitt. The CSD is more mounted than one area. We can also mount this. So we looked at the 4 places. We mount it at post-pick right after the feathers come off, so you can see what the incoming loads are from the blocks. We go to rehang, post-chill, your common process control samples, and then parts. So we can move from front to back and kind of get an idea. And we're starting to look at where we get our diversity, serotype diversity. When we sample more carcasses, we're getting more serotype diversity. On a regular single carcass sample, it's a hit or miss kind of deal. When you're doing 60 or 1,400, then you get much more bigger chance of getting those serotypes that are out there in any spot contamination, not homogeneous contamination. So that's where we're moving in the future. This is the data we're collecting right now, again, in commercial processing lines, and hopefully soon we'll have that idea of what's going to work going forward in the new lottings. I'd like to thank Dr. Tommy Wheeler. He was a co-inventor on the MicroTally with USDA Ag Research Service. Frank Reno was one of the technicians there that did a ton of work on this. And then the chicken processors, just so helpful to get the access and the support for these projects. So I'll end there, and if anybody has any questions, I can take any questions.